Hello dear students, as you all know, we are doing alternating current chapter number 7 is of your syllabus. We have done chapter number 6. We have done two parts of alternating current also. Today we are going to study about phasor diagram of different AC circuits. So what is phasor diagram we have discussed in the last lecture, and it was if alternate EMF is given by E0 sin omega t and corresponding alternating current is I0 sin omega t minus 5. So how we will be on the phasor diagram? I have told you for alternating EMF, if we draw phasor like this, so this angle is going to be omega t, this arrow length is going to be E0, and from here till here it is the value of E. Okay. So for current is omega t minus 5. So for current we have a smaller arrow. This will show current and this angle is going to be 5. Okay. Now here the current makes the angle with the x-axis is omega t minus 5. And what will be the corresponding value of current? From here till here it is current. And the length of the arrow is I. This is how we draw phasor. Now we are going to apply this particular concept in different kind of AC circuits, right? So let us start. The first, what we are going to study, we are going to study AC circuits. AC circuits. The first circuit we are going to study is circuit containing only capital R. What is capital R? Capital R is resistance. Okay, capital R is resistance. How the circuit will look like? So one resistance is connected, a source of alternating EMF, this is the R, this is the AC source. What is the voltage supply which we are giving over here? Alternate EMF is given by the source EMF. It is actually E is equal to what? E0 sin omega t. This is the equation number 1. Okay. So what will be the value of current? The alternating current is given by I is equal to E upon R. Okay, I is equal to E upon R. So let us put the value of E over here. The value of E is E0 sin omega t. We are going to have I is equal to E0 sin omega t upon R. Now that E0 denotes the maximum EMF, which is called peak EMF, right? E0 denotes the maximum EMF, which is called peak EMF upon resistance. EMF upon resistance is maximum current that is given by I0 sin omega. So this is the current. Equation number 2. Equation number 2. Here, that I0 is equal to what? E0 upon R. Right? Okay. So this is the current, this is the EMF, and you can see from the both equation, the phase of the current is omega t. Here the phase of EMF is also omega t. Basically in this phase, the phase of current and the phase of voltage is same. When we draw a phasor diagram of both, phasor diagram How it is being drawn? Just see. For voltage, this is your EMF. Okay. This angle is what? Omega t. And on the same arrow, since current makes also the same angle at that time, so what we are going to have? I, and it is also the same angle, right? And how we represent them graphical representation of them, graphical representation. How it is being represented, just see. For EMF, graph is of sin theta only. Okay, this maximum denotes E0. This maximum denotes in the negative direction minus E. Since current is flowing in the same manner only, I0 sin omega t. So for the current also the graph is same. Graph is this maximum value denotes I0 and this minimum value you can say negative maximum, it is minus I0. Right? This angle is phi, this angle is theta, this angle is pi by 2, this angle is 3 pi by 2. On this axis I am taking omega. Right? So this is how the current and voltage varies graphically. They are represented as graph in graph. Here, phasor array. Why both the arrows are on the same line? Because we have same phasor, omega t, omega t. If phases would have been different, suppose it has been from omega t minus pi by 2, omega t plus pi by 2, then the phasor will change accordingly. Right? So this is what? Circuit containing only R. Now let us move ahead. Let us do our next circuit. The next circuit is circuit number 2. Circuit number 2 is circuit containing only L. Okay, circuit containing only L. L means what? L is inductor. L is inductor. Inductance basically. And here I am saying that this AC circuit will contain an inductor. All we know that inductor has a property of inducing EMF or inducing current. How the circuit will look like? The representation of inductor is like this. The source of alternate EMF. This is the AC source. And this is the inductor. Its self-inductance is L. Now, alternate EMF source E is equal to what? It is E0 sin wave. Question number 1. Okay? Now just try to understand. If we talk about an ideal inductor, what is an ideal inductor? An ideal inductor has zero resistance. So there is no resistance. So in this case, the formula I is equal to E by R won't work. Why is it so? Because there is no resistance. Then how are we going to solve? What is the method we are going to apply? What is the trick we are going to use? I am going to use, just say here we have two EMF. Just see over here we have two EMF. One is the EMF of source and other which is induced EMF. So at any instant, EMF of the source plus EMF which is being induced, if you both are added, the answer must be 0. From which law I am going to say that? Which particular law is allowing me to say that EMF of the source plus EMF of the induced at any instant should be equal to 0? Why am I able to say that? From which law I am able to say that? I am able to say that because of Kirchhoff's law. Kirchhoff's law states that for a closed circuit, the net change in potential should be zero. So here the change in potential is the EMF is the source, EMF of the induced. If we add both of them, the answer should be zero. What is the EMF of the source? It is E. What is the EMF induced? It is minus L di by dt equals to what? Zero. If we transfer that to that side, we are going to have L di by dt is equal to E. Okay? If L is transferred that side, and let us put the value of E also, we are going to have di by dt is equal to E naught L into sin omega t. Right? Now dt is being transferred to that side, we are going to have di is equal to E naught upon L sin omega t dt. Now let us integrate it. If we integrate it, then di is equal to integration E naught upon L sin omega t dt. E naught upon L is constant, it is out of the integration sign. When sin omega t is being integrated, what we are going to have? We are going to have minus cos omega t upon omega. I have already told you in the part 1 of the lecture some of the very important integrations, and that one of the integration is that. Okay? Now this minus sign comes over here, we are going to have E naught upon omega L, and we can write as minus cos omega t. Okay? Now that if we want to compare the phase of current with an integration of di, obviously it is an phase of current which is omega t with cos, that negative, and phase of voltage it is omega t but with sign. So what we need to do, we need to make sure that this also varies in terms of sign. We are going to convert this in terms of sign. How we are going to convert this? Let us see. I is equal to, we can write E naught upon omega L, and the C for this we can write minus, for cos omega t we can write sin pi by 2 minus omega t. For cos omega t we can write sin pi by 2 minus omega t, sin 90 minus theta is equal to cos theta only. So we can write for cos omega t we can write this. Now this minus sign will make sure it goes inside in the function of sin. We are going to have E I is equal to E naught upon omega into sin in bracket. When this minus sign goes in the bracket, we are going to have omega t minus pi. But the standard equation of current is I is equal to I naught. So here I am going to say that I is equal to I naught sin omega t minus pi by 2, where I naught is equal to what? E naught upon omega. Okay. So the phase of the current when it comes into the terms of sine is omega t minus pi by 2, and phase of voltage is what? Omega t. So now we can compare phase both, compare the phase of both, EMF of phase of EMF and phase of current. Right? There is one more important discussion regarding this, but we will do afterwards. First of all, let us understand the phasor diagram. I am removing this so that we can understand. Let me write the equation which comes for the current. Current for it comes I is equal to I naught sin omega t minus pi by 2, and I naught is equal to what? It is E naught upon omega. After a whole lot of discussion, we have got this. Okay. Now let us draw the phasor diagram. Okay. Let us draw the phasor diagram. Phasor diagram of this circuit. Phasor diagram of this circuit. How it is going to be drawn? Let us see. First of all, for EMF, this will be, this angle is what? Omega. Okay? EMF makes an angle omega t. In that case, current makes the angle omega t minus pi by 2. So from EMF, we take a perpendicular and that too behind. Okay? That too behind. This will be the I. And this particular angle is obviously pi by 2. Okay? So what is the current? Current is behind omega t with an angle of pi by 2. So in this case, what we say? We say that EMF leads the current in phase by an angle pi by 2. Okay? How the graphical representation is done? From the graph, graphical representation. How the graphical representation of both the things are there? Let us see on a single graph also. The graph of current is this, sorry, EMF. This is your E naught, this is your minus E naught. This angle is what? Pi by 2. This is pi. This is 3 pi by 2. This is 2 pi, right? Okay. How the graph of current will go? Current is pi by 2 angle behind the voltage. Current is pi by 2 angle behind the voltage. It simply means that when the voltage is at pi by 2, current should start from 0. Current should start from 0. From this axis I have taken omega t. So from here the current will start. And then the graph of sin theta will be made. So graph of sin theta will be like at pi it will be maximum. Then at 3 pi it will be 0. Then at 2 pi it will be minus. And then after it goes like this. And if we extend it behind, so it goes from here. So it starts from minus E1 and this corresponds to plus E1. Okay? And if you are not able to understand how this omega t minus pi by 2 should be interpreted, just remember during the derivation we had total line I is equal to it was P naught upon omega, which is for the assumed as I naught, minus cos omega t. How the graph of cos omega t is? Like this. So what is the graph of minus cos omega t? Like this. Just see, this graph denotes minus cos theta. So you can interpret the graph from here also. Okay? And you can interpret the graph from here also. From wherever you feel comfortable, you can interpret the graph. Okay? So this is the graph of current when inductor is connected to an AC source. From here, we have seen that the current is lagging behind from the voltage by angle pi by 2. Or in other words, voltage leads the current by an angle pi by 2. Okay? So this is what the second circuit containing only L. Now we are going to discuss the third circuit. And the third circuit is circuit containing only C. What is C? What is C? C is capacitance. C is what? C is capacitance, right? So let us discuss the third circuit, which is capacitance. One very important thing. Okay. Let's start seeing the one that I remember. Before discussing this one more very important factor was there, and it was I naught is equal to E naught upon omega, right? So here that current, what we know that current is equal to voltage or the EMF upon the distance. This is the standard formula we know, and here we have got current is equal to voltage upon omega. It simply means that omega L has the same role to play as the resistance plays in the circuit. And what the role resistance has? It obstructs the current. Here omega L is something which obstructs the AC current. What we say? We say that we denote this omega L as XL, and it is equal to omega L. In place of omega L, we can write 2 pi f into L. What is it? That is frequency. And what is this XL? XL is called inductive reactance. And what is that? It has same role to play as the resistance plays in the circuit. So basically, it is the effective resistance offered by an inductor to AC. AC is what? Alternating current. So basically, here that XL is what? 2 pi FL or omega L. If we plot a graph between F and XL, it simply is going to be straight line because XL is directly proportional to F. We have got the formula 2 pi FL. From the formula we can say XL is directly proportional to F. Graph will be straight. Okay. So this is what inductive reactance. Remember the word? It is inductive reactance. Okay. Now we can start the third one. Third one is what? Third one is circuit containing only C. C is what? Capacitance. C denotes what? It denotes capacitance. So how the circuit will look like? One capacitor, then AC source, right? So this is your capacitor, this is your AC source. How that AC source works in the case of capacitor, let us understand. Suppose a capacitor is connected to the DC source and a key. In the beginning, the capacitor was discharged. As soon as this key is on, then what will happen? Charge from the cell starts flowing to the capacitor, and it will flow until the voltage of the capacitor becomes equal to the cell. Somehow, if this voltage is changed, if this voltage is variable, somehow if we are able to change this voltage, then what will happen? The flow of charge will be continued. Okay? So for a variable voltage, there will be a continuous current in the circuit. For a variable voltage, because the capacitor has a tendency to have its voltage equal to the cell, equal to the voltage of cell. So if this voltage is keep varying, then there will be a continuous current in the circuit, so that the voltage of the capacitor becomes equal to this. Same happens with an AC source. The alternate voltage, variation of alternate voltage is like this. It keeps on varying from here till here. The alternate voltage increases. Then here from here till here, the alternate voltage increases. From here till here, again it increases, but in opposite direction. From here till here, again it decreases and it becomes zero. Okay, so alternate voltage keeps on changing, and therefore we have a continuous current in the circuit. Okay, how that current will be calculated? Let us try to understand. So here the alternate voltage we have got, what is that? Alternate voltage source is E is equal to E naught sin omega, equation number 1. Okay, how the current will be calculated? For a capacitance, capacitor C is given by dq upon dt. Okay, dq upon dt. Or if you don't know this formula, you must be knowing this formula. Q is equal to C from here. That C is equal to what? Q upon V. Since here the voltage is denoted by E and it keeps on varying very rapidly with time, then what we are going to write? For capacitor we can write C is equal to dq upon dE. Change in E. Okay? From here, the dq can be given as C into dE. If we differentiate both of with respect to time, we are going to have dq upon dt is equal to C dE upon dt. dq upon dt is what? Current. C. What is dE upon dt? It will be d by dt of E naught sin omega t. After the value of E. Now that I is equal to what? E naught is out the integration. So E naught and this C into what? Differentiation of sin omega t is cos omega t. And differentiation of omega t again omega. So what we are going to have? I is equal to omega C into E naught cos omega t. Right? Now I is equal to what? Just I am rearranging the equation. 1 upon omega C can be written as, and this cos omega t can be written as sin pi by 2 plus omega t. Sin 90 plus theta is equal to what? Cos theta. So now what we are going to have? 1 over omega C. So I can be written as, the standard equation I naught, and this can be written as sin omega t plus pi by 2. Okay, sin omega t plus pi by 2. Here I naught is equal to what? It is E naught upon 1 upon omega C. So the value of current in this situation is given by this. Okay? The value of current in this situation is given by this equation. So the value of I naught is E naught upon omega C. Now let us compare the phase because we have all the equations now. Now we are going to discuss phasor diagram. Phasor diagram for current. First of all, sorry for voltage, and that is omega t, and this time the current omega t plus pi by 2 it is. So what we are going to have? We are going to have current somewhere here, which is at an angle pi by 2 from the voltage. So direction of current is this side. This is the phasor for current. If you take the angle of current from the x-axis, you are going to have omega t plus pi by 2, right? So this is the angle of current. And if we talk about graphical representation, how we are going to represent it? Graphically, let us see. For EMF, simple sine curve will be there. Okay? For EMF, simple sine curve will be there. This is your E naught. This is your minus E naught. Okay? On the axis, I am taking omega t. This angle is pi by 2. This angle is pi. This is 3 pi by 2. This is 2 pi and so on. How the graph of current will be there? So current is sin omega t plus pi by 2. If it is difficult to interpret from here, just interpret from here. It is cos omega t. And the graph of cos omega t is something like this. Okay? The graph of cos omega t is like this. So this is I naught and this graph shows what? Minus. Okay? So the alternate element will be in this way and the current graph of current will be in this way. Okay? So this is the combination of three individual circuits we have studied. In next lecture we'll study about combination of L and C, L and R and C and R. Okay? In the next video lecture I'll discuss about combinations, but before doing that, here a very important definition is, and that is I naught is equal to 1 upon E naught upon 1 upon omega C. Here that 1 upon omega C has the same rule as the resistance as because it is EMF upon resistance. What is the resistance of the circuit? It is 1 upon omega C. This is called capacitive reactance. Capacitive reactance, right? And capacitive reactance is given by Xc. And its value is 1 upon omega C. Or we can write 1 upon 2 pi Fc. Okay. How it will be defined? We will say that it is the effective resistance that a capacitor offers to AC. It is the effective resistance that a capacitor offers to AC. If you plot a graph to show the variation of Xc with respect to frequency, from here it is clear that Xc is inversely proportional to frequency. So the graph is basically 1 upon F. Graph is like this. Okay? Xc is inversely proportional to F. Sometime in the board examination you have been tricked. You are being asked the graph of Xc with respect to 1 upon F. Here we have 1 upon F, here we have Xc. In that case the graph will be straight line because Xc is proportional to 1 by F. Okay? So this is all for the day. In the next video lecture we will study about how the combination of AC circuits, AC elements are there. That is combination of inductor resistor, combination of capacitor resistor, and then we will study LCR circuit. So this is all for the day. Thank you.